So now we're going to have a situation called an incline problem. If you flip your page in your packet over to page 19, this is going to give us our example. And it's a wildly different situation than we're used to. All of our situations have dealt with horizontal ground that an object is sitting on and you're moving it from there on. Now we're going to have an object that is actually sitting on an incline that is a 20-degree incline, like that. And they say that this object is moving down at a constant speed. It's a 60-kilogram box, and they want to know what is the force of friction and what's the normal force. So those are a couple of things we have to do. First of all, our first step up here says draw the free body diagram of the situation. So what forces are acting on this object?
Gravity.
Gravity is the first one. Force of gravity points straight downwards. FG. Join a table. Force of gravity points straight downwards, just as it always does. What's another force that we have? The normal force. The normal force is directed perpendicular away from the surface. It's not always opposite of gravity. All of our experiences up to this point, it has been, but it's not always opposite of gravity. What's another force that's going to be acting in this case, Samir? Force of friction. The force of friction always opposes the direction of motion. So if an object is traveling down the incline, force of friction will be directed up the incline. So up until this point, we can see that if, this is just hypothetical, if I am making an XY chart, and please don't write this part down yet, if I'm making an XY chart, you know we will, but if I make one, I only have one force in the Y direction. I have sigma Fy, and it's a negative Fg. Every other force is not in the X direction, and it's not in the Y direction. And so it would say that we'd have to break it up into its parts, how much Y, how much X. Each one of these I would have to do. But on top of that, a lot of the times in these problems, they ask you, what is the acceleration down the incline? So that's not even in the X and Y direction. What is the velocity down the incline as you reach the bottom? How much did it actually displace as it went along the incline? All of these are in this kind of direction that goes like that. Avery?
So we would have to find the angles for those triangles?
Each one, like each equation, you would have an acceleration in the X and an acceleration in the Y, and you would have to find the resultant of each one. That's challenging, right? Because you have to not only break them apart in the beginning, but then you have to bring them back together at the end. So what I'm going to suggest here is a strategy to make this a lot more simple. The strategy that I'm going to suggest is instead of taking a look at things in the X and Y direction, as we always have, we have the Y direction and the X direction. Now I'm going to suggest that we take those axes and tilt them just a little bit. And our axes that we're going to be working with now are going to be directed like this. And they're going to be called the perpendicular and the parallel direction. And the reason is because it's perpendicular to the surface and parallel with the surface. We can immediately see that it's going to have a positive impact. Now, parallel with the surface and perpendicular. It's going to have a positive impact because my force is perpendicular. I have the normal force. I can place that in there now. I have forces parallel. I have a negative force of friction. Now, 2 out of my 3 forces are able to go right in there. Of course, I have a mass. They said that was a 60-kilogram skier. And then I also have an acceleration parallel, which we don't know, and an acceleration perpendicular. So as it turns out, there's only one force that I would need to break into components. Just one. And that's a lot easier than taking all of these and breaking it into components. All right? So far, so good. In this particular problem, we're on page 19, by the way, guys, in the packet. On this particular problem, we're going to be taking a look at a situation where the box slides down at a constant speed. So what does that mean about the acceleration in the parallel direction? If it's sliding down at a constant speed, Ryan?
0.
0, very good. And also, as a box is sliding down in the parallel direction only, it is not going to be accelerating perpendicularly off of the incline. So that is also going to turn out to be 0. Now, the last thing that we need to do is we need to take a look at this force of gravity, because that force of gravity is not in the parallel or perpendicular direction. So we need to break this apart. This is my big hint to you guys. When we're breaking it into components, put it into the perpendicular direction first. So this would be FG perpendicular, the perpendicular component of it. Do that one first, and then draw the parallel component, FG parallel. The reason why you want to do it in that order, perpendicular first and then parallel, is because then this 20 degrees here is going to also be 20 degrees here. Whatever the angle of the ramp is here at the very tip will also be the angle closest to the box, but only if you draw perpendicular first and then parallel.
So are the purple one going down for force of gravity, that's going to be -9.8?
Right, this is still my negative force of gravity, right? So I'll have mass times g, and if I did 60 times 9.8, I believe it turns out to be 588 newtons, and it is negative because it points downwards. But what do you notice about this FG parallel? Is that going to be positive or negative? It's in the positive parallel direction. So I should have a positive FG parallel now listed on my forces. And what about this perpendicular one? Is that going to be positive or negative? Negative, because it actually points in the negative perpendicular direction. So negative FG perpendicular. These two red forces are really easy to calculate, because if I know that this hypotenuse is 588, then again, just like we did with our component problem, this would be 588 times the sine of 20 degrees, and this one would be 588 times the cosine of 20 degrees. So whatever values you happen to get here, you could go ahead and plug into your knowns. The remainder of this problem is actually pretty straightforward. This problem is asking, what is the force of friction? If my F net, the product of these two things, is equal to 0, that means that the sum of these two things have to equal 0. So if we're asking what is the force of friction, all I would need to know is what is my force of gravity parallel, and I should be able to do it. And that was easy to calculate right here. Force parallel is 588 sine 20. So when I do my F net parallel equation, it'll equal 0, and so the sum of the forces will equal 0. Likewise, the same process happens here with F net in the perpendicular direction, that's 0, and the sum of those forces will then also have to equal 0. And so Fn is going to be equal to Fg perpendicular. That won't always be the case. That's only the case this time because these accelerations were 0. Okay?